All right. So as I said in our warm-up there, we've got the distributive property. This idea of multiplying is called the distributive property. It's sometimes called expanding. And you'll also hear me call it rainbow. Okay? So we'll see that. Oh, how about I unfreeze it? It's kind of called expanding because you're taking the 12, you're kind of expanding it out and into the 10 and the 2 and doing that. The same with the X, you're expanding it out. But you're getting it so that it doesn't have any brackets, okay? And then you can do some of the operations. So this idea of expanding or distributive law is there. And of course, then we just finished doing the algebra tile way of imagining it. But this area model, whether it's this, or if you actually draw like an area like this, is a good way to imagine the multiplication that happens when we're doing this with letters and algebra. So the distributive property says this. To expand, you multiply the term outside the bracket with each term inside the bracket. So this X gets multiplied by this B, or sorry, this A gets multiplied by the B. And this A gets multiplied by the C. And when you do that multiplication, A times B is simply AB. That's a way of writing A times B. And then we have to multiply the A by the C and get AC. This is the formal mathematical definition of this property, but we'll use it with numbers. It makes more sense. And if you are, when you rainbow or when you're multiplying, if you have a positive times a negative, then of course we'll end up with a minus AC. Doesn't matter if inside it's plus or minus, you're going to rainbow that way. Now here's proof that the distributive property works. So we have a question here, 8 times 5 plus 4. Now, this could have been a question that we did on the first day because we practiced BEDMAS. So BEDMAS tells me to do what first? Brackets. And it means the operations inside the brackets. So if I was doing this, I would say, okay, let's do the operation inside the brackets. 5 plus 4 is 9. So BEDMAS would tell me to do that first. 8 times 9. 8 bracket 9. Then we can do the multiplication. And what's 8 times 9?
72.
72. Great. Let's try the box method. So in the box method, it will look like this. Have a width of 8 and have a chunk that's 4 and a chunk that's 5. Or sorry, a chunk that's 5 and a chunk that's 4. So let's break it up into each area, this area or box. What's 8 times 5, that multiplication? 40. And 8 times 4, 32. Add those up, what do we get? 40 and 32? 72. So if we imagine this as an area model, we still get 72. Now let's try the rainbow method. 8 times 5 plus 4. The distributive law. Even though it's kind of silly to use the distributive law right now, I would totally do BEDMAS and be done really quickly. Let's see if it works though. So the distributive law says multiply the 8 times the 5. 8 times 5 is 40. And then the 8 times the 4, well, we already did this, didn't we? Is 32. Add them up, and we get 72. So since we get 72, regardless of the method, All of these methods are valid. You get to pick and use whichever one you want. For me, in this question, I think BEDMAS would be easiest, right? You do the adding, and then you multiply by 8. But it's good to know the other methods work. And why is it good to know if the other methods work? Because sometimes the multiplying you're doing is this. BEDMAS would tell me to do the operation inside the brackets. Can I do that? Can you do x plus 4? No, how come? Different? Do you remember the language? Yeah. Different terms or unlike terms. So you can't do BEDMAS. You have to do the operation inside the brackets? We can't. We're not allowed to. But we know the other two methods work, including rainbow. So let's use that method to multiply. What's x times 2? 2x. X times 4. Oh. Times 4, 8. Is it a plus 8 or a minus 8? Plus 8, so we just write down. Plus 8. And I've been able to multiply even though I couldn't do the BEDMAS. And can I go any further? How come? Unlike terms. 3 times x, 3 times 2. Help me out here. What's 3 times x? 3x. And 3 times 2?
6.
Plus 6 or minus 6?
Plus 6.
So plus 6. You guys getting this down? Good. What's 4 times 2x? 8x, that's right, yeah. If you imagine it, we would have 2 x's. So imagine those rectangles. We got 2 of them here. There's 2x. And then we have 4 groups of this. Right? 1, 2, 3, 4. 4 2x's is a total of 8 x's. Okay. And finish this off. What's 4 times 1? 4 times 1 is 4. Plus 4. Good job. So now we can start using the rules from yesterday and the rules from today to be able to simplify pretty complicated algebraic statements. And remember, the first step of algebra is learning these rules to make our life easier. So let's write down example 2. This one says expand and simplify. So what that means is we're going to multiply, use the distributive law, then collect like terms. BEDMAS doesn't help us because we've got letters now. I know I'm supposed to do operations inside the brackets, but x plus 2 you can't do anything with. You can't do anything with x plus 3 or x minus 3. BEDMAS does tell me to multiply before I add, add, and you see that I'm adding this term plus this term. So I have to do the multiplying first, which is rainbow. Let's treat them like their own little questions. So what you should imagine is that all you see up the board is that. And in fact, I think, was that the first question that we just did? Or almost like it, right? 3 times x plus 2. So rainbow that part. 3 times x, 3 times 2. Does the 3 get rainbowed with this? No, it's not inside the brackets. That's too much. And you see this is multiplying. There's an add there. All right, so let's just do the little mini rainbow. 3 times x is 3x. So underneath, I write 3x. 3 times 2, 6. So plus 6. Now, imagine we've got another question. So I'm going to cover up the first part. And then you see that I've got this own little multiplication. Except this time I'm rainbowing a 4. What's 4 times x? 4x. That's going to be a plus 4x. And then be careful in this last one. What's 4 times negative 3? Negative 12. Excellent. A positive times a negative is a negative. So I'm not going to write down plus minus 12. Just minus 12. Am I done rainbowing? Am I done multiplying? Yes. All the multiplying's done. So check. I have multiplied. I have expanded. But now it says simplify. How come? Does that question not look familiar? This is what we did yesterday. Collecting like terms. So before, when I did rainbow, I said, can you go any further? You would say no, because of unlike terms. Can I go any further here? Yes, because there are like terms. Which ones are the same? 3x. Does it have a like term? What? 4x. And when I collect like terms, am I adding or am I multiplying? Adding. So imagine 3x is like 3 bananas plus 4 more bananas. How many do I have? 7x. 7 bananas, 7x. Are there any other like terms? 6 and negative 12. So be careful there. 6 kind of warm. And then subtracting 12. Where am I? Minus 6. What do you think I write down? Minus 6. I'll ask you now. Can you go any further? How come? Unlike terms. So we multiplied first, which is good. BedMath tells us to multiply. We couldn't do brackets first because we can't do the operations inside, but we can multiply. Then we simplified by collecting like terms. And an algebraic statement, which would involve a lot of steps if we found out what x was. If all of a sudden I said, oh, x is 2, you wouldn't want to, you don't need to plug it into all of this. You can just plug it into here, and this is much simpler. That's why we call it simplify. You want to try one on your own? Let's go over the whiteboards. Today is the last day of the week, so I'm going to give you the luxury of picking your own group, as long as there's no more than 3 people in the group. Okay? So you can go to any board you want. All right. Okay, so let's try this one. It's just similar to the one we just did. I'm just going to put the other one up just so you can see. I think everyone's got the question down.
Yes. Yes. These are like its own little separate thing. Because the two here, X becomes 2X. I got them because this 2 multiplied 4 to 8. Yeah, those are.
So your thinking's really good, but what's happening right now is you're confused because of your notation.
If you're done, you look around and see if you agree with other people.
So your 2 times x, which you said was 2x, right? And then you said, yeah, you got 8, right? So write it down underneath the multiplication. Don't write it in a different line. Okay? And then 3 times x, 3x, and right underneath, 3 times -1. Right? Even when you wrote it down here, you wrote it away from the negative sign, so you forgot your minus. Okay? So your thinking is perfect, but when your notation is a little confusing, you can make mistakes like this. I bet if you had written your answer underneath here, you would have found minus. Okay? So it's less than that. So I'm going to ask you to try and do that exact same thinking, but write it like this. Why are you saying 10? Okay. Thanks for telling me. This is an X. This is an X. It's like apples and oranges. Yeah. So you can't cut those. There you go, which is what you have written down. Okay, so now you already said the 2x and 3x. Yes. Yeah. So that's 8 minus 3.
Like sometimes we'll just like shave it down.
8 minus 3.
I don't know, just like I think that's like our jail.
Okay. Okay. Good.
All right, how did we do? What do we get? Nice, nice, nice. A few of you are writing the little rainbows. Do you need to write the rainbows? No? Some of you didn't need to. That's fine. But we did all get 5x plus 5? Excellent. Good job. All right, how about this one? Find the area of this rectangle. Hey. Nice writing paper. There's 2 ways you can imagine this. So, but the 1 doesn't go with the other.
Yeah, but minus.
Okay, that's separate. You can't minus it from x's. You can only minus it from other numbers. So do your 3x and your 3x. So again, there's one sideways. That'll work out. Trust me, I know you like to do it that way, but eventually you're gonna love the fact that you're working out. So even if you want to go underneath, put 6x underneath right now, you can. Okay, then. So what Landon likes to do is put these next to each other. So it makes it easier to see the atom. Now put the rest together, so -1. Plus 4. Minus. Okay, and then so let's try and do that. Immediate plus underneath. So -1 plus 4. 3, and then another 3. Plus 6. I really love if you're actually this bit, but you have the permission. Here we have to do variance. Okay. So I didn't want to stop it because it was right. That's right if you're finding it perfect. But I would like to imagine this gets broken up into 3x and a -1. 4 times 3x. Yes, good job. So it's 4 times -1. Yeah, -1. All right. Okay. Bring that together. Okay, great. It's 4 times -1. So that means I've got -1. And I've got 4.
This minus that happens to.
No, it's like the -1 is the red pile, right? -1 is that red little piece. And 4 times that means I have 4 red pieces. How many red pieces do I have? 4. And
So 50 is going to minus.
yeah, because a positive times a negative is going to be negative. Yeah, it's a great question.
I've always thought until now that you can't really times, like times a number to 1 because it would, it would still stay the same.
Yeah, no, you're right, and it is. So if I do 7 times 1, it's 7. It's saying 7 1.
She was dying like.
What's 7
And
times
so now,
1?
I literally was getting dressed and she. And the spot rice.
Those are great questions too. Right? It's good to get these questions. So when we're doing the area this time, this is like 4. That's 4 times -1. There's the area. Okay. Good job.
All right, so I'm looking around and I see 2 different ways to imagine this, and I love both ways, and everyone is getting the right answer. So the one way that people imagined it was they broke it into 2 sections. So they said, you know what? Let's break this up. Let's imagine this is 3x part, and this is a -1. So they're using the area model to imagine this. 4 times 3x is 12x. 4 times -1 is -4. So the answer is 12x minus 4. Others saw area as length times width, which it is. And you can imagine the one measurement is 4 times the width, you could say is 3x minus 1. And then now it looks like a question like rainbow. And I see people actually rainbowing. Boom, boom. 12x minus 4. Is one method better than the other method? No. The only thing that we're going to probably eventually want to recognize is that if we use the area model all the time, sometimes the numbers get really, really big and it's hard to draw an area model, okay? But we can use both right now. All right, here's your last one up on the whiteboards. Simplify, then evaluate.
So,
It's -5.
oh,
You actually forget the +3.
that's not.
This equation.
Yeah, x plus 3.
So now you're done with one, and now you're out. Now do your like terms. Four go. You multiply the 4 with this too. It's like 1.5. Well, this is 4. And this thing. That part. This is not equals 5. So this is almost 5 minus 5x.
It'd be like 2 minus 4, that's 3.
You can expand it, you should simplify.
No, it would just be 3 because you're like, yeah, 5. And
Show me more on that last step.
Yeah, we can add 2 to the 5. It's still big, so
Okay, hold on.
I'm having, so is, if you add 2 to 5, wouldn't it take that 2 and still make it -3?
That's right. That's correct. But we're not actually doing this because we have 4 times this.
They have 27.
Fine. You're close. Just another right number. So do that first. This is where your rainbow will your own self. Yep. And then it goes and multiplies with another. Yes. Okay. Does it keep going? No. So it's 4 times 2x.
that'd be 18.
Yes. So right down to 8. Yeah, 4 times 3. Oh, no, it's 4 times 3. Oh. 4. So it'll multiply.
Oh, yeah, sorry.
Yeah. 12. Okay, so plus 12. Right next to it. That's so plus 12. Does the 4 get multiplied with these guys? No, so you just write them down. Minus 5x. Plus 2. Okay. So from that whole thing, see how you change this to this. See how it all lines up nicely. Okay, so now you're up to like terms. Almost perfect.
Should I write?
So definitely 3x. And you collect the J12.
It's 8x minus 5.
Does that make it a little bit easier?
Negative 3.
Yes. Okay.
No, 8 minus negative 5.
It says now, evaluate. So now you know what X is. So you're now going to change it from 3 times X to 3 times 15.
It's not adding.
Nice. Okay.
So it'd be plus 3.
Oh, I see. Yes, I would.
All right.
Where the 6 come from?
Okay. Good. All right. So, love your first step. I see this across the room. See this rainbow? Does the rainbow keep going? Nope. Okay, just give me a second here.
Just write plus here.
Okay.
No, there's for some. Because you're adding 12. And then yes, is what I lost.
Okay. 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 Where did she go? Okay, so let's do this multiplication first. 4 times 2x. 8x. 4 times 3. So do I write down like this? Just 12? Plus 12. Okay, good. And then do I do 4 times negative 5? No. So since I'm not doing that operation, I just write this down. I haven't done anything to those. So it just goes like this. I really love that you guys are getting better at working down so we can see the next step. Don't be afraid to remember to put equal signs at the beginning. Equal sign, because you're saying that this line is equal to this line. I multiplied. Multiply is what I'm supposed to do first. That's the expand part. Am I done multiplying? Are there any other rainbows to do? No. Can I go any further? Yes, because you have like terms. Which one is 8x with?
5x.
Is it 5x?
Minus 5x.
Is it important that I say minus 5x? Yeah, good. And so what's 8x and minus 5x get me? 3x. 8x is here, and then you're taking away 5, so you're at 3. Is there any other like terms?
Yes.
Yep. 12 plus 2, which is plus 14. I have now simplified. But now I can evaluate, because now I'm going to say x is equal to 2. So now instead of 3 times x, I'm going to say 3 times 2. The way I write this down is I use brackets, and we're going to get practice into using this a lot this year. 3 times x becomes 3 bracket 2. I am substituting the x with a 2 plus 14. We're going to want to write this step down to show me that step. I know today a lot of you just said 3 times 2 is 6 and went straight to there, and that's okay for today. But later we're going to want to write that down. You'll see why later. Plus 14, and so the answer is 20. Simplifying made this question simpler. That's the whole point. This is better than 4 times 2 times 2 plus 3 minus 5 times 2 plus 2. If I just substituted in the 2 right now, look at all the math I have to do. That 2 times 2 is 4 plus 3 minus 10 plus 2. 4 times 7 minus 10 plus 2. That's what? 28 minus 10 plus 2. 18 plus 2. 20. Much more complicated to substitute than make easier. Much better to make easier first, then substitute. Do you agree? That's why we're learning these algebra rules, to make our life easier. All right, great. You can erase that and come back down. All right, so practice. Page 166. And again, I've chosen not to give you all of them, just a couple. So you can try those.